Hello everyone. This is Priyanshu, Choubey, Assistant Professor of Risk and University. Today we will going to talk about the minerals and minerals classifications and element composition of earth crust and soils and fundamental of crystallography and crystal symmetry. So let's see what is the minerals and classifications of minerals. Last time already we discussed about it our introduction of minerals and rocks and minerals definitions and classifications. Uh, Minerals and element composition of earth crust and soil fundamental of crystallography and crystal and crystallography. What is a crystal and crystallography? Habit of crystal and interfere angle, crystal symmetry, four types of elements: center, plane, axis, and composite symmetry are used in describing a crystal. And we already discussed about crystallographic axis, standard unit, plane, and parameters of crystal, space, lattice, and internal structure of crystal, and brevis lattice, and Miller indicates. Now, today we will see point groups, crystal classes, and crystal systems. Point groups, crystal classes, and crystal system. Point groups as are defined as the number of ways the different symmetry elements are combined so that each of these element passes through the point of interactions of the crystallographic axis. 32 different sets of symmetry elements or point groups are possible, and there are 32 different crystal classes corresponding to this 32 points group. The 32 classes fall conventionally into seven crystal system, like uh, cubic, triangular, uh, orthorhombic, rhomboidal, hexagonal, monoclinic, triclinic. So, structure, properties, and weathering of soil solids, classification of solids. So, solids are broadly classified as a crystalline, as amorphous in a crystalline solid atoms, ions, and molecules are held in an orderly area having a long range order in all the three dimensions. Crystalline solid based on the nature of bonding between the constituent particles are classified into four main categories, like covalent, ionic, metallic, and molecular. solids. Covalent or network solids. Here, constituent particles or atoms, and the bond between the atoms are of a covalent nature. Example are carbon in the form of diamond, and corundum or silicon carbide. Covalent bond between a two atom takes place by a mutual sharing of an electron between them. One or both the electron might be contributed by one atoms. Covalent bonding usually takes place between atoms of same negatively, or between atoms of not different much in their electronegatively. Ionic solid. Ionic solid or constituent particles are ions of opposite charge held by a, coulombic or electrostatic force. Example KCl, clay minerals. This form of a bonding result, it's the two atoms A and B differ very much in electronegatively, so that a transfer of one or more electron occurs. Molecular solids. In molecular solids or constituent particles are molecular, and their intermolecular bonds due to a dispersion force or van der Waals force. Two completely neutral molecules are held together by a by held together by a instantaneous dipolar due to a imbalance in electron distribution. If two or more adjacent molecular uh, synchronize their electronic motions, then electron repulsion and can be minimized, while electron nuclear attraction is maximized. Metallic solids, it is three-dimensional array of positive ions held together by a pool of electrons, commonly known as electron C, which is formed from the contribution of a valency electrons by each neutral atoms. The electron in the pool are not localized in any particular region, but are spread over the entire lattice. Unlike covalent bond or metallic bond has no directional carrier. Metals can therefore be readily twisted, drawn into wires, or bitten into sheet. Close packing and other details of ionic solids. Close packing and other details of ionic solid. Most of the minerals present in the earth crust and solid or ionic solids crust and soils and are soils are ionic solids and are formed by bonding between large oxygens and the generally much similar metallic cations, principally silicon, aluminium, iron, ferrous oxide, and magnesium. The crystal structure of ionic solids composed solely of monoatomic ions is governed by two following relatively simple factors like the most efficient packing of the ions is desired because like a charge repel it is necessary to prevent two ions or two cations more cations from coming in a contact with each other. Most efficient packing in ionic solids of a minerals, the most common oxygens packed together in the most space efficient possible manner. Term as a closed packed arrangement and the metal ions cations fit into the interstatics statics of these ions. There are two disintegrable close packed arrange, hexagonal close packing, and cubic close packing. These are most efficient packing. Hexagonal close packing is in a close packing atom stuck together occupying maximum space or leaving minimum vacant space. In the like in the first layer, A identically spheres of oxygen ions are arranged in such a way that each space in is contact with the six neighbors. Now, while arranging the second layers B on the top of the first layer spheres the are placed in the dispersion of the second layer. From the third layer spheres are placed in the dispersion of the second layer, which are directly above the sphere of the first layer. In this scheme, the third layer duplicated the first layer A and next layer duplicated B and this lead to the layers being stuck in a pattern AB. Cubic close packing. In this close packing, first and second layer are arranged just like hexagonal close packing, but spheres of third layers are placed over a void on the dispersion of both underlying layers are not covered. So far, thus they do not lie direct over the atoms of the first layer. Insist the spheres of the fourth layer are directly over the top of the first layer. If the third layer is termed as a C and then the resulting structure as a ABC, 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 first layer, second layer or third layer. So top cubic close packing, a third layer is placed over avoid the both underlying layers as a show. Metal ions occupy the hole created in a uh, hexagonal close packing and cubic close packing arrange oxy ions and for ana ions these are an octahedral holes and second is a tetrahedral holes. The larger octahedral holes are created by a sick adjacent close packed oxygen ions, while the smaller tetrahedral holes are formed by the four adjacent closed packed oxygen ions. In figure shows the octahedral and tetrahedral holes. Tetrahedral, octahedral, or and other polyhedral arrangement of the ionic solids. The tetrahedral hole is formed by the arranging three oxygen atoms closed packed in one planes and the fourth oxygen atoms on the interstice of the three oxygen atoms. The hole formed inside the four oxygen atoms is called a tetrahedral because if imaginary lines are drawn by a joining centers of one oxygen with the other solid figure. A tetrahedron is formed with the hole at the center of the tetrahedron. Similarly, an octahedral hole is formed by arranging four oxygen atoms, the forms of square in one plane, and fifth and sixth oxygen atoms are placed in the interstices on the upper side and lower side of the plane. If we are drawn imaginary lines join the center of the oxygen atoms or solid figure, octahedron will formed. Mineral structure are composed in an ordered fashion from silica and aluminum tetrahedral, octahedral of aluminum, iron, octahedral of aluminum, iron, magnesium, uh, and various other polyhedral where am symbolize the metallic cation. They form according to certain rules originally and numbered by the goldsmith letter refined by a following that minimize electrostatic repulsion force between adjust cation and maximize attractive force between the cation and anion. In an anion crystal, atoms will be arranged around each cation in the shape of a polyhedron. In purely ion bond, there is no overlapping of electron orbits between on anion and cation, so the bond length is equal to the sum of ionic radius of the cation and anion. It can be derived by the simple geometric that the number of anion around the cation, which is called the coordination number, depends upon the relatively size of or radii of the cation and anion. Any pair of cation and anion have a radius ratio uh, to 0.2252 to 0.414 will form the tetrahedral coordination between 0.4112 414 to 0.732 octahedral coordination between 0.032 to 10 cubic. A ratio of 1.0 will form dodecahedral coordinations. Classification of silicates. Minimum ratio of coordination number of commonly found in minerals, that is very important. Coordinations number and polyhedron are minimum radius ratio. So coordinations number 4, 6, 8, 12. 4, 6, 8, 12. Polyhedron, tetrahedron coordinations number 4 and maximum radius ratio 0.225 and octahedron coordination number 6. Minimum radius ratio 0.414 and cubic polyhedron coordination number 8, minimum radius ratio 0.732 and diode do, dodo dodo hec- hectohedron minimum coordination number 12 and minimum radius ratio 1. Some important line here. In some cases, pairs of cation and anion having the same radius ratio may form more than one types of coordinations. For example, the radius ratio of aluminum coordination to oxygen is radius 0.36. The aluminum ions is also predicted to occupy tetrahedral hole and does so in a many primary minerals, but since the radius ratio is sufficiently close to limiting value of octahedral coordination, 6 coordination of aluminum ions is also common. In fact, under low temperature and pressure condition that prevail during a secondary minerals form, the 6 coordination of aluminum is more common than 4 coordination under alkaline condition, or aluminum ions have favorable tetrahedral coordination, and under acid condition, aluminum forms octahedral coordinations. When covalent character develops in ionic bonds due to overlapping of orbits of the cations and anions take place. In that case, the predictive accuracy of the radius ratio falls. For example, the sulfide minerals. Sulfide minerals has an ratio of 0.53 and predicted cadmium coordination number of a 6. Yet cadmium is a covalent bonding between a cadmium and sulfide minerals. So polarizations, when a high charge cation will small size of bond to large size anion, the electron orbits of the ion is pulled towards the similar ions and overlapping to the orbits take place, resulting in the shortening of a bond length, and the some covalent character is brought into the ions bond, and the hence strong linkage is created. Classification of silicates minerals. Classification of silicates minerals. Summary of structure of different layers. Silicates minerals are characterized by the presence of silicon oxygen bond. In addition of silicon or oxygen, the other ions present in these minerals are aluminum, iron, ferrous oxide, magnesium, manganese, lithium, titanium. Silicates are classified in a different group according to number of the silicon oxygen or silicon linkage present in them. This is the equivalent to the number of the corners. The silicon tetrahedron is sharing its oxygen with the adjacent tetrahedron. The groups are followed like neosilicates, orthosilicates, or Iceland silicates. Classification of silicates, mineral silicate class, the unit composition arrangement of silicon oxide. So, neosilicates, sorosilicates, uh, cyclosilicates, inosilicates single chain, inosilicates double chain. So polysilicates, and last one is the tactosilicates. So silicates made of silicon and oxygen, and silicon silicates made of silicates and oxygen make up about the 96% of minerals found in the earth crust, and silicates includes feldspar and quartz. uh, uh, Minerals group minerals group silicates and carbonates. Two types of mineral groups are available. Carbonates made up of metals bonded to a carbonates use CO3 to inverts, and carbonates made up of metal bonded to a carbonates and found in the limestone, malachite, and the marble. And minerals group are silicates, carbonate, and oxide. Oxide are made up of metal bonds to oxygen, and oxide are made up of metal bond to oxygen, hematite, iron oxide, and magnetite, and a magnetite or common iron oxide minerals. So minerals group silicate. Four types of mineral groups are available: silicates and carbonates, oxide, and halides. Third one groups are mineral silicates, carbonates, and oxide on halicides and native elements. So here's some basic information about minerals and minerals. Uh, and a system of minerals, and also we discussed about it, a tetra octahedral and other polyhedral arrangement of the iron solid and classification of silicate minerals. Next video we will see about nilosilicates and orthosilicates and isolate silicates. Thank you. Yes, and lichen grow on the exposed rocks. They facilitate the deposition of dust, resulting in a higher plants getting a favorable environment to grow. As a result, root of higher plants penetrate inside the rocks and disintegrated them physically. The mosses and lichen growing on a rock's secret chemical adjust which act chemically on the mineral present in the rocks and the tends to form new minerals, borrowing animals movement of animals and the human activity, cultivation, land leveling, construction of the roads and the buildings, railways also facilitated the physical weathering sequence of minerals. Mineral present in the soil, the parent material under various environment conditions differ in the layer. Their degree of weathering. Generalized sequence of the mineral is ordered to their weathering resistance in other under quartz more resistance moscovita more resistance and moscovita and K feldspar sodium calcium feldspar biota and hornblende the ignite aluminum dolomite and uh, gypsum is a least resistance. This sequence is comparable to a weathering sequence proposed by Goldick in the year 1938. The degree of weathering may vary depending upon the climate and other environment conditions. Soil formation factors is a process, a pathogenic process, most geological process. So upliftment and of mountains and Iceland operate very slowly in the nature, but is the pathogenic process. Although the slow in terms of a human life, but proceed at a faster rate than a geological process to convert the parent material into a mature soil. showing a distinct nutrient ABC. The pathogenic processes are extremely complex and dynamic, involving many chemical and biological reactions, and a different process or combination of process operate under the influence of the soil forming factors. The basis of process involved to operation of soil forming process are uh, addition or gain of water, mineral, and organic matter in the soil, loss of the above materials from the soil, transformation of mineral and organic matter mineral materials within the soil, transfer and the translocation of energy and matter. All this promote differentiation by way of the transformation of soil materials, minerals, and organic matters, resulting in the release of soluble salt and carbonates and oxide, silica, clay minerals, and organic acid, and their subsequent translocation with the percolation water and the deposition and the various depth. Classification of the process. So pathogenic process are simply a recognition and a rearrangement minerals and the organic soil constituents in the different layer under the influence of the various pathogenic factor. This can be broadly classified into two groups. First one is fundamental pathogenic groups process in humification, eluviation, also called the immigration is specific pathogenic process. The fundamental pathogenic process are collectively lead to the formation of a number of soil that are the found on the surface of the earth. This process provide a skeleton for the operating specific pathogenic process. In the fundamental process, if the pattern of a deposition or a removal of the soil material is specific, then these are kept under a specific pathogenic process. A specific pathogenic process can be categorized into two groups: the zonal groups. Zonal group, the soil formation process that are occurring under the prevailing condition, climate, and Biosphere also by active factors. These are threaten or equilibrium with their surrounding environment and due to course of time. So calcification. This process occur in a arid and semi-arid climate. Process of the precipitation and accumulation of the calcium carbonate after the mobilization from upper soil layers in some part of the profile. Calcification result in the formation of calcic horizon. K. It can be represented by H2O plus a carbon dioxide is equal to carbonic acid insoluble plus 2H CO3 is equal to calcium bicarbonate soluble. Calcium compounds mobilized by the acidification of the water are kept in solution as long as the supply of carbon dioxide is maintained up to a critical level. Below this level, the carbonate are precipitated as white powdery filling in the soil pores. Later on, a soil matrix is converted into an indurated vein having a hard, spiny nodules of a calcium carbonate. Reverse decalcification. Refers of the calcification, that is a process of a removal of the calcium carbonate or calcium ions the soil by a leaching process. The pedolization. The term pedolization divided from a Russian word pedo means under, pod means under, and jol means ash like. True pedozol are except some reports of pedozole like a soil pseudopodozole from a high altitude area Himachal Pradesh and Jammu Kashmir and eastern northeastern state. Pedozolation is a process of acid hydrolysis. Acid has a favorable factor climate, cold and humid, vegetative, acidic nature. And parent material sandy. High rainfall coupled with the sandy present material favorable in sister leaching because cation like sodium, calcium, potassium, magnesium released during a weathering leach out of the profile. The pH of the soil remains below 5.0 due to the leaching of a basis. Under the acidic environment and the cold climate, polymerization of the simple organic acid is very slow due to a sluggish bacteria activity. Thus, organic acid either along on the combination with the saxo oxide. Chillet move to low chile layer and deposited by in a B horizon due to increase in bacterial activity. In silica being insoluble at a low pH remains at the upper layer, and the saxo oxides due to higher solubility. Under this condition, move down to dead deposited in the boron horizon, where a slight increase in the pH is in country. This polarization in a soil formation process which humus and oxide become mobile leach out from upper horizon and get deposited in a lower horizon while a silica remains accumulation in upper horizon. Laterization. The term latera is divided from a Latin word later means bricks or tile. Favorable factors warm or warm, humid vegetation, broad leaves, tropical vegetation, basic nature, parent material, basic parent material that contain high iron and ferromagnesium, mineral pyrohexane, amphipoles, and biota and chloride. High rainfall favorable intense leaching of a basic cation, sodium, potassium, and calcium, but due to a basic nature of parent material and vegetation, soil pH remains alkaline or neutral. Silica being a soluble in alkaline condition leach out the profile, whereas ions and aluminum oxides are released during a weathering remains insoluble and coat the soil matrix and impart the characteristics red color to the soil. Uh, in this process, most of the silica leach out and soil wears a relative proportion of iron and aluminum oxides. Saxo oxide is high in the soil. The laterite oxisol The laterite oxisol and laterite altisol are mainly used for shifting agriculture, low intensity grazing, and the growing plantation crops with adequate nutrient supply. Anthrozoal and the soil forming process. This pathogenic process are more influenced by certain local conditions such as a relief or parent material than a climate and vegetation, hydromorphic and halomorphic and chalkymorphic soil. And jelly means a Russian word refers to a blue gray green clay gelination. The process result in a development of a jelly's horizon G in some part of profile due to a poor drainage condition, dispersion land, imprevious or salt parent material lack of variation. Under depleted oxygen condition, iron compounds are reduced to a soluble, whereas from most of the irons exit as iron or organocomplex soluble, whereas from most of the iron exit of the iron organocomplex in a solution or the mixed precipitation of ferric and ferrous oxide, which impart a typical bluish to grayish color to a horizon, distinct mottles to of a yellow of a rusty brown color on a matrix of a gray horizon are a are often found where alternate oxidized and reduced condition prevail due due to fluctuation of water table with the season. The reddish mottles contains high amount of irons than the surrounding blue and gray matrix. Salinization, the process of accumulation of salt such as the sulfur and the chlorine and calcium and magnesium. Soil in form a horizon leading to development of saline soil. The soil is considered saline if EC electrical continuous salinity saturated extract gather zero 4.2 decimal internal pH is more than pH is less than 8.5 and ECP less than 15. These soil are also called a white alkali soil, contain mostly chlorine and SO4 and calcium magnesium with less amount of uh, carbonate and HCO3 and sodium. This soil are formed under arid and semi-arid climate when evaporation losses uh, are the most than precipitation salt released during a weathering accumulation soil area having a high brackish ground water dispersion land and a poor drainage condition also lead to the formation of saline soil. If a groundwater followed by a evaporation springs and upward movement of capillary water followed by evaporation result in accumulation of a salt and soil surface in the root zone. Although physical condition is saline soil good due to a presence of calcium causes population, but high osmotic pressure due to excess soluble soil solution, restricted availability of water and nutrient to plant, resulting in a poor growth. Saline soil could be a reclaimed simply by a leaching with a good quality irrigation water. If the leaching is not good then artificially drain network need to provide a flush out salt from affected. The process of accumulation, alkalization, solonization, the process of accumulation of sodium ion exchange complex of the clay resulting in the formation of alkali, sodic, and this soil are also called a bulk alkali contain most of carbonic and hydrocarbonic sodium and the less amount of the chlorine and uh, sulfate and calcium, magnesium. All contents in soil solution are the engaged in the reversible reaction with the exchange sites on the clay and the organic matter particles. As the soil solution dries, most of the carbonic and the calcium and magnesium is precipitated in the soil solution much before the sodium. There's a sodium carbonate, which is 100 times more soluble than a calcium and magnesium carbonate. Thus, the sodium remains in the soil solution and its absorption on exchangeable sites, clay and organic matter is increased. The dominate of the sodium and the exchange site causes a dispersion of a clay, leading to a poor physical condition of a plant grow. Increase the soil pH is more than 8.5.